Okay, so lesson 26 is derivatives, specifically derivatives of e to the x and natural log of x, and derivatives of sine x and cosine x. And then we'll also look at an exponential growth and decay problem on the backside, I believe. Okay. The two derivative lessons we've had before, well, the two derivative shortcut lessons, it's all been focused on, okay, if it's x raised to some numerical power, how we deal with that. And that's, you know, we have that basic rule. The four derivatives we're going to talk today come out to, I don't have a better way to say it, it's memorization. You just need to memorize what is the derivative of e to the x. What is the derivative of natural log of x. Same thing for sine and cosine. Okay, we'll use them a lot, but they're just ones that you have to know. Okay, I don't have a way for you to figure them out easily, you know, or anything like that. You just need to know them. So, okay, guys, right up there, the derivative of e to the x. So right here, what it's saying, when it says d dx of e to the x, that's saying the derivative of e to the x is e to the x. It is the easiest one we'll ever memorize. The derivative of e to the x is e to the x. It's itself. It does not change. Okay? So, and I should say the derivative of e to some power is e to that power. Okay? Derivative of natural log of x. The derivative of natural log, and officially it says of the absolute value of x, because we know the inside of a log cannot be negative. Derivative of natural log of x is 1 over x. So the derivative of natural log of something is 1 over something. Okay? So those are the two rules we're going to use in the top part of the notes here. So example 1. Find dy dx. So find the derivative, given that y equals 4 natural log of x minus 6 e to the x plus 2x squared. Yes. So like yesterday, remember yesterday we learned sums and differences to find the derivative of each term. So we're going to look at this individually here. So I'm going to write dy dx 4 natural log of x. So what did we learn yesterday? Because this is the other part of what we learned yesterday. That 4
is an exponent. Or it could go to the exponent, right? Or we're not going there.
We're not going there. That'd make life way more difficult. It took me a moment to figure out what you were saying. No, just yes, going back to yesterday when we're taking the derivative, the 4 is just a constant out front that's going to carry down. Okay? We're not doing anything fancy with that. We just carry the constants down. And then the piece you're taking the derivative of, ln x. What is the derivative of natural log of x? 1 over x. So this is going to be 4 times 1 over x. I will come back and rewrite my answer and we'll clean that up. Okay? I'm going to carry down my minus sign. The constant of 6, just carry down, times, what's the derivative of e to the x? Most difficult one ever, right? So derivative of e to some power is still e to some power. Carry down my plus sign.
4x.
Derivative of 2x squared? 4x. That's what we learned yesterday, right? And Maddie, I don't know if you've looked at yesterday's notes or anything, but that 2 exponent, we multiplied out front. There's already a 2 there. 2 times 2 makes it 4x. And when you subtract a power, 2 minus 1 is 1. Okay, there's really only about one piece that I would clean up here, and that is that 4 times 1 over x. How can 4 times 1 over x be written nicer? 4 over x minus 6 e to the x plus 4x. That is what you would usually expect to see as the derivative here. Now, as we get better about this, do you have to start with 4 times 1 over x? No, you'll go right there. You'll realize, okay, the 4 stays on top. Derivative of natural log of x is 1 over x. Okay. I don't normally write at the bottom of the board, but I don't have, you guys aren't in a class where you're trying to peer over each other's heads, so I'm going to go ahead and use the bottom of the board here. before I move it up. Example 2. Find dy dx given that y equals 4 natural log of absolute value of x minus 6 e to the x plus 2x squared.
Would it not be the same?
It is pretty much the same. What's the only difference here?
Is that since it's ln to the absolute value of x?
Yeah, the only difference here is that this one is specifically specifying that the absolute value is we're going to only use positive. So only positive values of x. But other than that, the plan is the same. Okay? So it's still natural log of x is 1 over x, put it under 4. We still have a 6e to the x, and we still have a 4x. So there's really no difference in how you express your answer. It's just kind of indicating the absolute value there. Okay, so are you guys okay if I just rewrite the answer? dy dx is 4 over x minus 6e to the x plus 4x. Okay. Questions on the basics here? Okay. Shall we look at the bottom half here? Now I do have to, in order to scroll my screen, I have to get out of the way I'm doing it today. At least I have to get out of the easy right and scroll my screen. But it is, if I'm, it is still in the recording. So there we go. Okay, bottom half. 2 new derivatives to learn. So you've got 4 total today to learn. The derivative ddx of sine x. So the derivative of sine of x is cosine x. So the derivative of sine of something is cosine of something. Okay? Not to be confused with the derivative of cosine. The derivative of cosine of x is negative sine x. Okay? I'm not sure I have a great memorization technique on these. Other than you just have to, the more you use them, you'll know them. Okay, so let's look at example 3. Find the derivative of y equals 3 sine x minus cosine x plus 2e to the x. Now, when I write that out front, what should I start with? Even before that, before the equal sign, what should I start with? Okay, you can use dy dx. You could use y prime if you want to. There's several different notations you can use there. So, derivative of 3 sine x. The 3 will carry down. Derivative of sine x, we just said up top, was cosine x. So that's going to be 3 times cosine x. Minus, I'm going to carry my minus sign down.
Minus negative sine x, so it's going to be plus sine x.
Yeah. The derivative of cosine x is negative sine x. So this is kind of my work step. So I'm going to write it as minus negative. Honestly, if I wasn't doing this work step, I would, yes, go straight to the plus. This is the only day you'll see me do that work step. I will usually go straight to the plus. Okay, derivative of 2e to the x. So the 2 will just stay the same. And what is the derivative of e to the x? E to the x. As I said, I'm doing a little bit of a work step today. I won't normally. So dy dx equals 3 cosine x plus sine x plus 2e to the x. Okay. I will randomly say the one disadvantage of this video, and I haven't figured out a way to avoid it, the tapping my pen makes.
Does it record that?
It does.
And is it extraordinarily loud of a thing?
It's louder than I wish it was. And I haven't listened to, I've tried to tone down tone down my tapping, so I'm hoping maybe it's a little bit better, but how do I avoid that? I don't know how to avoid that. So, Okay, bottom one. Find the derivative of y equals negative 3 cosine x plus 3 natural log of x minus 2 sine x. Okay, here we go. I'm going to start by writing dy over dx. Okay, derivative of negative 3 cosine x. Yeah. Okay, if I do it in the baby steps, as I said, I'm just using those today. The negative 3 we carry down. The derivative of cosine x is negative sine x. So I do agree we'll multiply those together in the next step. Plus, okay, derivative of 3 natural log of x. The 3 we will keep. Derivative of natural log of x. 1 over x. Okay. Minus derivative of 2 sine x. So the 2 I'm going to keep. What's the derivative of sine x? Cosine x. Okay, if you haven't already cleaned it up, and I don't know, some of you guys may have just said, I'm not even doing her baby steps. I'm just writing the answer. That's fine. 3 times negative sine x, excuse me, negative 3 times negative sine is going to make this 3 sine x. 3 times 1 over x is plus 3 over x minus 2 cosine x. Questions there? Okay. I will say, yes, you have to tolerate the tapping if you watch the video, but I don't know. I personally think it's going to freeze. I personally think the video with the tapping is better than the laggy video. I don't know. Maybe the lag will get annoying. Now, sometimes when I scroll to the next problem, yes, it gives me an error, but it keeps recording through that, so that's the good news. I'm wondering if I make my file smaller, which is on my plan, it'll work better.
We just have a random name exponential.
Well, it is kind of thrown that, and the book kind of does that sometimes. I mean, we have been talking exponents with e to the x, and I think that's the key you want to look at as we're talking about e's here. So, okay, exponential functions. The form we are talking about for exponential functions, if a of t equals a naught times e to the kt. Okay, that is the exponential functions. Now, this is one of these forms that carries on through calculus. Okay, we're not just using it today. It's not a one and done. It will keep coming back, you know, as we go through various things. Now, t, of course, stands for time. Now, I don't know what Dr. Austin does. I read that as a naught, a zero, a...
Yeah, so Mr. Kevin would usually say a naught or just a initial.
Okay. So, regardless, however you think about that, and you know, a of 0, a sub 0, a of 0, a naught, it's the original. It's your initial amount is what it is. Okay? A of t is the amount at time t, and k is our constant, which represents the growth constant. So, a big part of these problems is we usually have to solve for k before we can solve for what they're asking for. So we're going to have to find, based on the given information, what is k, what is that constant, before we can work the problem. So, okay, number of bacteria present at noon was 400, and 9 hours later, that bacteria numbered 800. Assume exponential growth and find an equation that describes the number of bacteria at a function of time t, where t is measured in hours. And I would just stop reading there, because then it says, then find. We'll come back to that later. Okay? Because that's after you get your equation, we'll find the number of bacteria present at noon the next day. Okay. So what are some things we picked up on?
We have the initial value, and we have the time.
Okay. Number of bacteria present at noon was 400, and this is going to be my initial value, because that's the first amount we know, right? That's a naught, and that was present at noon. We know time, meaning 9 hours later is my T. And the bacteria numbered 800. That's your A of T, yep. And I'm just kind of numbering, labeling things within the problem, what they are. Assume exponential growth and find an equation that describes the number of bacteria as a function of time T. So, if we fill in our equation up there. Okay, we were given the equation A of T equals A naught e to the KT. What do we know? We know everything except K. So our first job is to find K. 800 equals 400 e to the, K times, there we go. K times 9, which I'm going to go ahead and jump and write 9K. Okay. K is in that exponent. I don't know, equation solving skills here. Dig deep. We're trying to solve for K, which is in an exponent. How do we get e to the 9K by itself first?
Do you take like
in a moment?
Okay.
After we divide by 400. So we will take the natural log of both sides to pull that exponent done, but we don't want to do it until we just have e to some power. So yep. So we're going to divide by 400, get rid of that coefficient. So then I'm going to have 2 equals e to the 9K. And then once we have that, yes, because it's e to some power, we're going to take the natural log of both sides. Because if we take the natural log of e to the 9K, what we do to one side of the equation, we're going to do to the other side of the equation. So then we have the natural log of 2 equals the natural log of e to the 9K.
So then, am I right in saying that the L and E's would cancel on both sides, which is 2 equals 9K, or not? It would be natural log of 2 equals 9K?
Yeah, we don't want to go back to saying 2 equals e to the 9K because then we're still stuck with how we solve this. Okay? What you need to remember here is that natural log is base e. And since that's base e and that's e to the 9K, it's just 9K. Does that sound familiar? So you end up with 9K equals natural log of 2. And obviously then K is going to be natural log of 2 divided by 9, which is some decimal, which I'm going to work with it right now because I don't want to have to write a decimal to carry it through. So I'm just going to leave that right there. And I wrote natural log of 2 over 9. The book might do 1/9 natural log of 2. I don't care. They're equivalent, right?
Because you've done left, right, middle.
Yes. And you'd get the same result, right? Yeah. You're talking about right here, and we had e to the 9K equals 2. You do a reverse left, right, middle, then it jumps you right there. Yeah, that works too. Okay, everyone okay with how we did that? Now, so, I guess we still haven't officially written our equation, have we? Because when it says write an equation, basically we want that equation, I'm going to come up over here, A of t, we want just a basic equation for what A of t is. And A of t, well, what do we know about A naught? 400 e to the kt. What's k? Yeah, ln 2 over 9 times t. I don't know. What did I? Yeah, I wrote it like that. So that is our equation. And then what do we have to do to finish this off?
Find how much bacteria is in the thing at noon the next day.
Bacteria present at noon the next day.
So 24 hours. So T would be 24.
You guys like Ross's T is 24? My initial was at noon, and then now we're trying to find noon the next day, which is 24. That's 24 hours. So we're finding A of 24. So 400 e to the ln2 over 9 times 24. And this is probably the hardest part of the problem. How do I get it in the calculator, right? And there's, there's right ways to put it in the calculator and wrong ways. So, but you do need to, it's the calculator at this point. And this is the one thing I can't do is I can't project my calculator now onto the recording. However, at this point, as long as you're sitting in class, I can still use the Elmo. So. E to the, and this is, I don't know. 2 over 9, and you could put the times 24 in the numerator, or we could just put it out there. It just has to stay in that exponent. Does your answer match my answer? Does my answer match my answer key? It does. Okay, so my calculator answer, see, however you do it, make sure you get something equivalent to 2539.841683. Which, we're going to give a more appropriate answer than that now. This says find the number of bacteria. In this particular problem, I have it as a whole number. Because we're talking bacteria. This is where I hesitate because it's calculus. Which, AP, we keep seeing 3 decimal places, but in this situation, you wouldn't give portions of bacteria. You'd usually give whole bacteria. So I'm going to say approximately, should put approximate here, 2,540 bacteria. Bacteria. There we go. Okay. It is random and away because it's not derivatives. However, throwing the E in there. So, okay, we'll do a lot. This will keep coming up. In homework, we'll see other lessons on it eventually too. So, okay.